Hello and welcome to the LeetCode Larry Show. I am your host, LeetCode Larry, the only person on the planet named LeetCode Larry whose name is not actually Larry. Today, what is LeetCode Larry going to do? LeetCode Larry is going to do some LeetCode. What kind of LeetCode are we going to do? Well, today I think we're going to look at some graph problems. Which graph problem are we going to look at? One would say the most fundamental, the most important graph problem to look at for interviews, at least. Maybe not in the real world or in graph theory, but for interviews, this is one of the best problems to start off with here. It's called number of islands, LeetCode number 200. Let's go ahead and read the description. So, given an n by n 2D binary grid, so it's going to be like a 2D array here, which represents a map of ones, land, and zeros, water, return the number of islands. So we look at this. This is the grid here. It's a 2D array. It's got ones that represent land and zeros that represent water. So how do we know how many islands are here? Well, let's look at the definition here. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. Now that's key. You may assume all four edges of the grid are all surrounded by water. So that's key that it's surrounded by an island is connected adjacently, horizontally, and vertically. So in this one, in this first example, we can see that there is one island. Now, how do we know that? Well, we can see all these ones. This one here is connected to it. And these two ones, and these two rows of ones are connected to it. There's only one island here. Because this whole part is only, it's all connected. All the ones are actually connected each vertically and horizontally. But here, I think this is a better representation. This is a better way to get a conceptual overview of what an island is. Here, we actually have three different islands. We have these four ones at the top here, at the top left. And this whole one here is its separate island. Now, why is it its separate island? Isn't it connected to this and this? Well, no, because these are actually connected not vertically, diagonally, not horizontally or vertically. So above this one, we have a 0. To the left of this one, there's a 0. To the right of this one is a 0. And below the one is a 0. So we know this one is all an island by itself. Similarly, on the bottom right here, we just have these two ones. They also represent an island. So the three islands are these top four on the left, this one right here, and these two on the bottom right. So there are three ways to approach this problem. There's depth first search, breadth first search, and there's another one called disjoint unions, and we might do that one later, but for this video, we're just going to use depth first search and breadth first search. Okay, so how does it work with depth? We'll start with depth first search. Actually, I think that's an easier way, but it's less efficient. So how are we going to do that? Well, let's go to our handy dandy chalkboard. All right, so how do we find the number of islands here? As we said before, there should be three islands. This top set of ones on the left, this one all by itself, and these two ones that form an island in the bottom right here. And we know that because the ones are connected either vertically or horizontally. They cannot be connected diagonally. So how do we use that information to find the number of islands? The key is to use that information to identify an island. So every time we identify an island, we can just increment a counter of the number of islands. So we do some classical set a counter equals 0. We do some sort of loop, and we loop through this structure here, which will be a 2D array. And then every time we find an island, we increment that counter. That's sort of the high level of how we want to do this. But So we know we have a counter. We want to increment it every time we have every time we find an island. So the question is, when we loop through this, if we just loop through this 2D array, so we start here in the very first element. We can identify that that's an island. But if we go to the next element, there's another one, so is that another island? Well, no. So what we need to do is somehow mark this as being visited. So in the solution I'll give, and the solution for that LeetCode gives, is to mark it as a 0. So when you're solving this sort of, when you're solving problems in LeetCode and interviews, you sort of want to ask them if it's okay to modify the given data structure in place. We're going to do that for this case. Maybe I can make another video, a follow-up video, how to create another separate data structure. But for now, we're just going to take this input to the array, and we're actually going to iterate through every element. Every element's going to be either a 1 or a 0. And if we visit an element, we're going to mark it as 0, so we know that's visited. But, so, back to the question of how do we iterate through these elements? What does depth first search mean in this particular situation? I don't know where to put my chalk. Oh, here's my magical chalk. Okay, so we start up here in this 1. And at the beginning of the loop, like I said, our counter is going to be initialized to 0. Since we found a 1, we know that we found an island. Now our counter is going to be initialized, well, it's going to be incremented, and now it's going to have a value of 1. So what do we do here? Well, here, to do a depth first search, when we say depth first search, it actually means we're going to, search, when we say depth, it means we're going to search all the way until we find a 0. So we're going to process this element, and we're going to create a separate method, sort of, to do this. We're going to run a depth first search on this element here. What are we going to do first? First, we're going to mark this as 0. Yeah, I can go ahead and just mark it as 0 right now. And then what are we going to do? Well, to do that first search in this situation, we're going to go all the way left, all the way right, all the way up, and all the way down. And each time we do that, every time we go down, we're going to do one of two things. If we're looking at a 1, we're going to mark it as 0. And then we're going to recall the depth first search on this element. In other words, let's say we start from the top and then we go down. Since it's a 1, we're going to call depth first search again. We're going to go right, left, up, and down. But when do we stop? Well, let's say we end up going down. Let's say we get here to this 1. This one here. Let's say it's the, let's say we process this one already and marked it as 0. So now we get here, what do we need to do? We need to mark it as 0 also. Okay, we're going to go left, right, down, and up. Okay, but let's say we go down, or left, or right, or up. So the order in which we do this is going to be arbitrary, but we'll just say we'll start left, then we go down, then right, then up. You can do this anyway. But there's going to be a couple situations. So when we hit a 0, we're just going to return from the method. We're not going to do any more processing. We're not going to have to mark it as 0 because it's already a 0. And we won't have to do any more searches because we've already left the island. So we're not part of the island anymore. There's no more island to process. Another situation could be, I'll forget this particular example now, but let's say we're here, all the way to the left, and we go left once again. Well, we can check our bounds, and we'll notice that we're again off the island, so we can just return. Why are we off the island? Because we're not even in the realm, we're not even in the array anymore. We're not even in this whole array of ones and zeros. So in the code, we can just basically check if we're still in the bounds of the array. So if we're above the bounds of the array, or to the left of the bounds of the array, or to the right, or to the bottom, we're going to automatically return. Or if the element we're looking at is a 0, we're going to automatically return from this depth first search method, this depth first search function we're going to create. Otherwise, if the number is a 1, like here, we're going to mark it as 0, and then we're going to call depth first search on the left, on the element to the left, on the element above, on the element to the right, and the element below. So we're going to recursively call that method to search on all 4 elements to the left. So when I say all 4 elements surrounding it, so the element to the left, the element above, the element to the right, and the element below. Now it's okay, even when we get to the bottom here, let's say we get here to this 1, we're still going to call the depth first search on the element below. But again, like I said, at the beginning of the method, we're going to check first if we are in the realm, if we're in the bounds of the array. So we'll just call the method, check the bounds, we'll automatically return. We won't have to do any more work. Now, when we do that, so let's go back up here to these top 4 ones. Once they're all marked as 0, we're gonna call the depth first search here, and we're gonna end up marking all 4 of these as 0. Then after that's done, we're gonna have a 1 for our number of islands. I'm gonna keep going across. When we get down here, remember we marked it as 0, so we will not find another island. That's the whole point of marking them as 0, so we don't get the incorrect number of islands. But when we get here, I erased that earlier, but remember this is a 1 at the beginning. When we get here to this island, we're gonna go ahead and call this again. We find the new root, basically. Find a new island, a new 1. So now the number of islands is going to be 2. All right. So then what happens? Well, this will be changed to a 0. We're going to call the depth first search this way, this way, this way, and this way. So left, up, right, and down. And then at the end, we're going to get to this 1. What do we do? Well, it's a 1, so we can go ahead. It satisfies all conditions. It's within the bounds of the array. It is a 1, so we're going to mark it as 0, and then we're going to run depth first search. And in the process of running depth first search, one more thing, one more key critical point, to increase the number of islands to 3. In the process of calling depth first search, we're going to go left. Here, this is 0, so we're automatically return. Go up. Here, this is 0, automatically return. Go right. Oh, here's a 1. We can mark that as a 0. Mark that as 0. And call depth first search again. And then once we're done with depth first search there, we'll come back here. And then one more place we have to check is down here. Oh, but it's out of the bounds of the array, so we can go ahead and return. And then, as you can see, there's a little bit of repetitive work here. Once this is finished, you go here and you do search here one more time, but it's a 0, so we automatically return to the method. So there's a little bit of room for improvement. I mean, you'll see that in the breadth first search, but that's how the depth first search works, and that's the whole key to the algorithm. All right, boys and girls. All right, guys and gals, ladies and germs. And that's all I can think of. Let's just get back to the coding. So let's go ahead and write the algorithm to detect the number of islands in the grid. So once again, we're given a grid. The grid is just basically going to be a 2D array. So in Python, a 2D array, it's actually going to be a list of lists. So yeah, actually here, I didn't even notice, but here in this little doc string, it gives you the type of the grid. It's list of string. Each number is actually going to be a string. It's going to be a string of a single 0 or a single 1. So let's go ahead and go over the algorithm that we discussed. So at first, what you usually want to do in this kind of coding problem, you want to check the edge case. You want to check if the grid is empty or if the grid is null. So if grid is none, or length of grid is equal to 0, that means one of two things. The grid is none, that means the grid is null. There is no defined grid object. If the length of the grid is 0, then that means it's just empty. So we're just going to go ahead and return 0. Return 0 islands. Basically, we didn't find any islands. Okay. So next, what do we want to do? Well, let's go ahead and add some class member variables of the number of islands and the number of rows in the grid. The number of rows and the number of columns in the grid. So rows will be horizontal, columns will be vertical. So let's create two class member variables, self.rows. Let's initialize that to length of the grid. So the length of the grid will actually be how many lists are in the 2D list. And self.columns will be length of grid of 0. So that's actually going to be how many elements are in each row. So we already have our two member variables. Now we can go ahead. Well, first let's set number of columns, number of islands equal to 0. So obviously we want to start off with 0 as our number of islands before we iterate through the grid. Okay, now we can iterate through the rows, through the columns. We can process each element individually, and we're going to run our depth first search helper function on it. So let's go ahead and give a quick sketch of that. Look at my notes. For a row in length, well, actually it'll be rows. No, range of rows. For row and range rows. So we're looking through the number of rows here. And then for column in range columns, it's actually going to be self.columns. Sorry, so this will actually be self.rows. I forgot to add the self keyword here, because this is actually a class variable. And what are we going to do here? Now, at each row and column of the grid, so the very first row and the very first column will correspond to the very top left element. We're going to go ahead and run our depth first search recursively on this element. So for now, we're just going to do first we're going to check if the value there is equal to 1 or 0. So actually, let me take that back. We're not going to run depth first search if it's a 0 value. We're only going to do it if it's a 1, because that's how we know we're on an island. So if grid of row column is equal to 1, then we have to do two things. First, we have to increment the number of islands. And then we can run depth first search to go ahead and set all of the ones on the island to zeros. That's the whole point of this depth first search. So we don't have duplicates and count islands twice. So we're going to do number of islands plus equals 1. That's the way in Python to increment a variable by 1. Then next we're going to run self.depth first search. We'll call it DFS. We haven't defined this function yet, but we're going to get to that. And that's going to take in the actual grid. We're actually going to mutate the grid variable. The row number, which is just row, and the column number, which is column. Check my notes if that's it. Yes, so we're going to have the grid itself, the row, and the column. And the editor is complaining about DFS because we haven't defined the function yet. And after that, well, so that's it for each element. We're just going to do that. We're going to check if it's a 1 or a 0. And if it's a 1, we're going to increment the number of islands. And then we're going to run the depth first search function to set all the ones on the island to 0. And then after we're done with each element, well, we can just return number of islands. So there's only one thing left to do here. We had this whole number of islands method finished. This is all done. This is good to go. But we still have this helper method, this DFS method to finish. So let's go ahead and create that. Define DFS. It's going to have 3 parameters. Well, every Python member method, every method in Python is going to have to start with self. It's also going to have 3 parameters: the grid, the row, and the column. So what are we going to do in this depth first search? Well, if you remember from the algorithm we sketched on chalkboard over here, we're going to process the first element, then we're going to go down and mark each element 0 until we find a 0. Then we're going to go left, mark each element 0 until we find a 0. Then we're going to go up and mark each element 0 until we find a 0. And then again for the right. But before we mark an element 0, we have to check 2 things. If the row is less than 0, so we have to, basically what we're doing here, we're going to check the bounds. So we want to check if we're even inside the bounds of the grid. And what are the 4 checks we need to do there? Well, we're going to check if row is less than 0. If row is less than 0, then we're not in the grid, because you can't be in index -1. Or if column is less than 0, similar logic to row is less than 0, then you're not going to be in the grid anymore. Or if row is greater than the length of the row of the grid, which we have defined up here, or if the column number is greater than the length of the columns of the grid, which we have also defined up here in this self.columns variable. So here, what is this all going to be all together? If row is less than 0, or if column is less than 0, or if row is greater than self.rows, or if column, or if column is greater than columns, or if column greater than self.columns. So those 4 conditions will check if we are in the bounds of the grid. Now there's just one more thing to check. Well, we have to check if it's a 1 or a 0. Because if it's a 0, we can just stop. We know we're off the island. We don't need to mark anything else. So we've already reached the end of the island. We're in the so-called water territory at this point. So we do, or if grid of row column is equal to 0, and if any of these 5 conditions hold true, we're just going to return. But if none of these conditions hold true, that means we're in the grid and we're at a 1 value, so we're still on the island, and we still have to keep recursively running this DFS function. And we still have to continue marking 1s to 0s on the island. So we're going to have to do 4 separate calls here. First, before we call those 4 separate calls, we're going to actually mark the current grid, the current 1 value, to 0. Because that's the whole point of doing this DFS method. We want to mark the values to 0. So grid of row column is equal 0. Okay, and then after that, as I was saying before, we want to go ahead and recursively call the DFS method 4 times. And what do we want to do that on? So we're going to do a self.dfs, and we're going to call it on the grid on the current row plus 1 and the current column. So that's going to go ahead and call it on the element to the right. Then we're going to call self.dfs on the grid, row minus 1, and the current column. That's going to call it on the element to the left. Self.dfs, grid, row, column plus 1. That's going to head and call it to the element. That's going to call it on the element below the current element. Self.dfs is our last case, grid, row, and column minus 1. That will call DFS the element above the current element. Now you might be thinking to yourself, well, we can't call self.dfs, we can't call DFS on, well, let's say we're all the way to the left here. We're on this 1 right here that I'm highlighting. We can't call DFS in row minus 1, can we? Because there is no element to the left of this element. Well, that's the whole point of the check we're doing here. So in this DFS method, the very first thing we do is we check and see if the current indexes are actually within the bounds of the grid. And if not, we just go ahead and return, and we move on to the next call to DFS. So this will recursively call the DFS methods, continuing on until it marks all of the ones in the current island to a 0. And again, why are we doing that again? We're doing that so we go ahead and mark. So once we mark all the elements in the current island to 0, we know that if we continue to iterate through the grid, we will not have duplicate number of islands. So that should be it for the DFS method. And we also have the number of islands method up here. And that should be it for this solution. And if by some miracle I typed everything out correctly, we will get a correct solution. I highly doubt it, but let's give it a try. Oh, it's accepted. Alright, I doubted myself, but I got it. First try. Even though I do have notes right by me. But yeah, so once again, this is the DFS depth first search approach to the number of islands problem. This is one of the very basic fundamental graph problems you'll see in a LeetCoding interview. And DFS is probably the simplest solution, but breadth first search, which is also one of the 2 fundamental graph algorithms, depth first search and breadth first search are the 2 fundamental graph algorithms. Breadth first search is actually a better approach to this problem. So in the very next video, we're going to go over BFS, breadth first search. I will see you all there.